Hey guys, today we are going to talk about an industrial application of EM waves, which is the non-contact tachometer. So we've all used this in our labs, but have we ever wondered how does this work? So what is a tachometer? It is an instrument which measures the working speed of an engine or any rotating device, typically in revolutions per minute, that is RPM. The basic working principle of the non-contact tachometers is quite simple. It works by detecting the time intervals the light takes to reflect off the reflecting surface of the body. There exists a mark, or in some cases a reflecting surface on the body rotating, whose angular speed needs to be measured. So now let's divide the tachometer into three components to better understand it. One is the IR emitter, second is the sensor, and third is the signal processing module. The IR emitter continuously emits a ray of monochromatic IR rays. The sensor continuously senses for incident IR radiations. In a bit more detail, the sensor is essentially a photodiode which produces a voltage pulse when photons of a specific radiation are incident on it, and hence what happens is that when the radiation emitted by the emitter is incident on the photodiode, a sudden surge of current is generated, which is then passed on to the signal processing module. So what the non-contact tachometer does is, it emits infrared radiations of the body unlike contact tachometer, and then it measures the time interval after which it detects the reflected radiations which are reflected from the mark or the reflecting surface on the body, and then calculates the frequency of pulses using signal processing module. From this information, we get to know about the RPM of the rotating device. So now that got a bit boring. Let's discuss it this way. So now this is the rotating part and this is the tachometer. The tachometer sends the rays which is reflected and collected by the photodiode. It senses the signals and the signals are further sent to the signal processing module. These signals are represented like this, which shows the frequency. When we take the Fourier transform, we can easily find the frequency of the signal, which is then converted to RPM. Having seen that, let's discuss the role of EM waves. The non-contact part in the non-contact tachometer is very important, since in a lot of the industrial applications the speed of rotating body is so high that it is not possible for us to measure its speed by bringing any instrument in contact with the high speed rotating body. As we know from the working of tachometers discussed, that it is essentially the electromagnetic waves that allow us to measure the speed without actually having to measure the instrument in contact with the rotating body. From here till here comprises of one cycle of rotation, and therefore we can find the frequency and hence the RPM. One of the most used concepts in industrial applications is the concept of feedback. It ensures precision, which is of great importance in industrial applications. And one of the most important components of the feedback systems are the sensors. Sensors in the feedback system are just devices that measure the physical quantity that needs to be controlled. Tachometer is one such sensor which is used in applications where the angular speed of the system needs to be controlled according to the need demanded by the application. So there are various utilities of the tachometers. They are used across many industries. Some of them are the aerodynamic systems, the petrochemical industry, and the rail industry, and there are a lot many more applications of tachometers. So these are the references. Thank you for watching. I hope you enjoyed the video.